Welcome back to another episode of the Become Limitless podcast. So, again, I'm going to reiterate that I'm doing a YouTube channel as well now. So, if you want to listen to this on a different platform, so this will be available on YouTube when the public version of this podcast is available. So, let's get into the first episode of this season. And I want to start off with a big one. So, why we age. And I want to give you some tips and tricks that we can do straight away that we can start to implement into our lives that can let us live a little bit longer. And not even the case that we live a little bit longer, that we might be able to live better, live healthier, and not have as much disease and not have the cancers and things like that. That's what's being looked at now in the sciences. So I wanted to bring this to you so that you could really understand and really start to implement these things straight away that'll allow you to live a healthier and more substantial life. So the first thing we're going to go over discussing is, what does that even mean? How do we even look at aging and how we can change the way we think about aging, and why it's very important we look at aging as a disease rather than something that's inevitable, which we've all been told. You're just going to age. That's what it is. We're going to look at the 8 or 9 hallmarks of aging. We're going to look at how aging creates disease, like getting older then obviously amplifies the disease you could get. Going through those little tips and tricks and the little things you can do right now that will allow you to live a healthier life. So we're going to start looking at aging as a disease. And when we can look at aging as a disease, where it allows us to really gain an understanding of that disease is something we can cure. Disease is something that we can prevent. Disease is something we can start to do, things we can do in our daily lives to lessen the ability to get this disease or have this disease affect us. So when we talk about disease in other aspects, we can cure it. We can look at it. We go, well, how come people aren't doing these things to lessen the effects of the disease or to stop them getting the disease in the first place? And that's why I want to talk about having aging as seen as a disease is so amazing and so limitless, and you're able to become limitless from it, because being a disease that it is, because there are certain genes in your body and certain environmental factors that create aging. And when you look at the basis of aging and the way that the cutting edge science is telling us, talking about aging, is that our bodies don't necessarily need to age. Like the whole functions and everything goes on, they don't need to age. And aging really comes down to the fact that it's a loss of information. That there's the genome that we have, our DNA, and that's a digital readout. And that digital readout doesn't get damaged. You've heard many times, if you've been on scientific websites or anything like that, that you can find mummified remains or frozen remains are 4,000 years old, and they can pull the DNA off that and have a look at it, so they can read the DNA still. It's not the fact that the DNA gets damaged, it's the part on top of that, the epigenome, that starts to get a bit hazy. The information gets lost, and then obviously your cells stop, they start to forget what they're supposed to do. Your hair changes color, it forgets what color it's supposed to be, or you start to create cancers and things like diseases like that, because the cells start to forget what they're supposed to do, what they're doing properly. So that's when you're younger, your cells know exactly what they're supposed to do, and when you're getting older, biologically, not chronologically, there's 2 different things there as well we'll talk about. And biologically, if you're not getting old, when you get older, your cells are technically forgetting the information they're supposed to have, or the readout from the DNA, which is digital. And I forgot to mention that they look at the epigenome as analog, and there's a reason for that. There's a whole different reason. So it allows it to be flexible and allows it to do a lot of different things, the epigenome. But the epigenome, if you've listened to my podcast earlier, controls the readout of that DNA and what it wants to do and how it wants to express the DNA in regards to the environment that it's in. And for a cell, it's the blood, and how the blood gets that information is from the brain. The brain perceives the environment we're in, whatever stressful situation we're in, It then sends chemicals, all the neurochemicals, different chemicals from around the body into the blood. The blood then signifies the cells, and those cells then have the epigenome do their thing, express, downregulate, upregulate genes. And when we do that, obviously we can turn things on and off, longevity on and off, and all those things. That's what they're looking at now, that these sirtuins, I hope I'm saying that correctly, sirtuins, I think they're called sirtuins, are a little bucket of, I think there's 3 buckets of genes that they talk about. The mTORs, so mTORs, and there's some AMPKs, and then there's also sirtuins. And those 3 buckets of genes, because there's a whole host of genes inside those buckets, but realistically what they look at is the mTORs, you want to have react with amino acids. So the less amino acids you have in your system, the less that activates, I believe. I will have to look into that a bit more, but that's how that works, and that creates a longevity. It creates a state of defense. The body goes into a defensive state. You could also look at the AMPK, which we want to boost, which happens when we don't eat, when we fast. AMPK upregulates and it starts to turn on the defenses. It creates longevity in our cells, creates our cells, allows our cells to replicate, our cells to repair DNA, repair all the damage that gets done throughout life, because life is just, that's how it is. We also look at the sirtuins, and exercise activates sirtuins, and all those, there's 7 different sirtuins. So it gets really, really detailed, and I will get to more information in later episodes. But for now, just know that there's 3 buckets, and that's the things we want to influence with some of our lifestyle changes we're going to implement at the end of the episode, which I will cover, sorry. So you can see that it's a disease. If we can do things to prevent this aging from occurring, this damage or misinformation from the DNA into the epigenome, that it's giving the wrong information. If we can start to prevent that, and there is cutting edge technology, I won't talk about it in this episode, but there is cutting edge technology about how we can then jump back or go back to an earlier stage in the cell, obviously preventing aging. You could jump back in life, back to a 30-year-old, like myself being 30. So now let's get into the hallmarks of aging and what that actually means. So hallmarks of aging is genome instability caused by DNA damage. So you can look at it like X-rays and other chemicals and things like that. They'll damage your DNA and they'll break the DNA. Your body is really good at repairing DNA. It does a really good job at that. But when it's doing that, it's not creating a longevity. It's not doing the things to create longevity. Okay, so that creates the genome instability. The more times that the DNA is damaged, the more times it has to go over and has to keep repairing this DNA that keeps breaking apart, the more it creates instability, the more the information that starts to get distorted in the epigenome. That's how you create genome instability. That's how you get old, how you age. Your cells start to change, you start to forget what they were. You start to get obviously the hair growing in different places that one's supposed to, and all the weakening of the body and everything like that. And the next thing is attrition of protective chromosomal end caps, the telomere. So that means these things at the end of your DNA, telomeres, and the longer they are, they used to regulate, like I said, the longer they are, they used to dictate how long you have to live, or how long you get to live, if you've got long to live or short time to live. Now, the longer they are, the more time you got. The shorter they are, the less time you got. That's what they've looked at. So it's another hallmark of aging. So the shorter they are, normally you look at a person and go, they're older. They've aged biologically by the length of their telomeres. So that's what that whole the protective chronological end caps. They're the caps on the end of the DNA that obviously dictate. So obviously the shorter they are, the less protective they can be. Alterations to the epigenome that controls the genes that are turned on or off. So you're down-regulating or up-regulating the genomes that control those. Okay, so if you alter that, then you don't get the protection that you're looking at. You don't get the protection from the epigenome or the genes doing their thing, trying to protect the DNA and the information that's being passed backwards and forwards, or passed out. No, it is backwards and forwards. So when it gets passed backwards and forwards, whether it's upregulated, downregulated, will allow you. So if the gene is to help with the longevity or to help protect the cell, more upregulated is better. The better it's turned on, it's better for the cell life, for the cell to grow, to live longer, that longevity. So the next one is the loss of healthy protein maintenance. So when we talk about that, we talk about the proteins are created from our DNA, from an epigenome. That's what happens. It goes in there, it does a whole host of different crazy, awesome chemical things and creates proteins. Proteins allow us to do everything in our life. Like everything is relied on proteins within the body. So for us to lose healthy protein maintenance, so the proteins are starting to get not ideal, not the best case scenario, then therefore it will suffer. Your body will suffer. You'll show you are unhealthy. If your proteins aren't healthy and maintaining themselves correctly, then you will lose that health. The next one is downregulated nutrient sensing caused by metabolic changes. Now, if we can't sense the stuff coming into us, or the foods and the drinks and the water and all that kind of stuff coming into us, and we can't understand that there's a lovely balance when it comes to all this thing. Like there is a lovely balance with everything we do, and our bodies are amazing at trying to balance, keeping that balance. If we lose the ability to sense the nutrition in the, I just had to check, make sure the podcast is still running, sense of what's going on, nutrition, so we haven't got enough of this, have we got enough of that, we've got too much of this, we've got too much of that, we're trying to bring it down. If we haven't got that balance, then the body starts to show aging. If you see older people, they can't balance their insulin, say, or they can't keep certain other aspects, amino acids, whatever the case may be, essential things at balance. They start to go out of balance. That's why normally there's a lot of medications being put on top to try and balance these things out, like regulating blood pressure and all those kind of things all come to chemicals and hormones, and the body's ability to balance and regulate all that obviously shows aging. That's the hallmark of aging. So these are things I know I'm getting pretty full on here, it's a lot of information, but these things allow you to see that someone is aging. The more you see these things happening, the more you know that they're biologically aging. So the next one is accumulation of senescent zombie-like cells that inflame healthy cells. Now these are the cells that don't get destroyed. They're cells that die off, but they stay around, they hang around, and they just sit there and inflame other healthy cells. Now the very important part about that is that these senescent cells, these zombie-like cells, do accumulate over time. So the more senescent cells we have, the more we have a problem starting to inflame other healthy cells. And obviously another sign of aging, isn't it? So the more of these senescent cells we have, the more we biologically have aged. Exhaustion of stem cells. Stem cells are the building blocks. We get a stem cell, then the epigenome reads the DNA saying you need to be whatever cell, a skin cell, a muscle cell, whatever it is. It evolves into, it gets turned into a skin cell, whatever it is. The more that this exhaustion of stem cells, so they're seeing more exhausted stem cells, ones that are not changing what they're supposed to be, they're giving you the different hair color, they're not growing on top, they're just thinking, those kind of things are a show of biological aging. Altered intercellular communication and production of inflammatory molecules. Now, that is another one. We can see that inflammation markers, the communication between cells and what they're supposed to be doing and working in obviously connection with each other and working together as a team, because we've got trillions of cells in our bodies, and this stuff happens all the time in crazy quick times, and the tiniest little things you can't even, like, it's amazing how our bodies are working under the surface that we just don't know, we just aren't aware of as well. So when that intercellular communication and production is obviously altered and it creates that inflammation of the molecules, that's another sign that we're aging. And all these things have got answers. We can start to slow or reduce the amount of damage that these hallmarks have on our bodies. That goes into, again, what happens we can do in our environment, and things that I want to give you at the end of this episode, which is coming up very shortly. I'm just going to cover another little quick topic, but that will show you that these hallmarks we can reduce. We can lengthen our telomeres. We can obviously avoid damaging our DNA unnecessarily. We can alterations to the epigenome, we can control that. Loss of healthy protein maintenance, we can do things in our bodies to change that. The downregulated nutrient sensing caused by obviously the metabolic change, we can help that as well when it talks about keeping a steady energy level through the body. We talk about accumulation of senescent cells. We can do things that can remove those senescent cells, let the body do its job. So many different things we can do that allow us to reduce these hallmarks of aging, and obviously decrease our biological age, and allow us to live longer. Okay, things we can do right now. So I said at the start of this season, which is last episode, I wanted to give you actionable steps that you can take from every episode to obviously become limitless, to get to what you want to do, to become the person you want to become, and obviously living a healthier, longer life. And I'm not even talking like you get to your 80s or 90s and you're feeling really good still. You feel like you're a 30-year-old. You're feeling strong like you're a 30-year-old. Is a much better fate for everyone. Less disease. That's what we want ultimately. So what can we do? The first thing is it's be uncomfortable. Is the very first thing I want to talk about is just being uncomfortable. And all these next little things that I'm going to talk about is all about being uncomfortable. And our body being uncomfortable turns on all these longevity genes, the 3 buckets of genes that I was talking about earlier. And that allows you to obviously let the body do its thing and heal itself. And what you can do straight away, sorry, just had a bird hit the window there. So what you can do is you can really, really, really easily do these things, and they don't take any effort whatsoever really. Fast, be hungry is the first one, and it's the one that I've been trying to do more often. I'm starting to do my own fasting regime is now a 16 and 8, where I'll have an 8-hour window of eating, 16 hours where I don't eat at all. I'll get all my calories for the day within that 8-hour window, and then I won't eat for 16 hours. So I'll fast from 4 o'clock in the afternoon until around 8 or just after 8 o'clock in the morning. So it's the best way for me to do it, best way for me to get it in. I've never really struggled with eating dinner. I didn't really need to eat dinner. I never felt like I had to eat dinner. But, and breakfast, I've always been hungry in the morning. So I've always wanted to wake up. I've always wanted to get straight into food and get into it. So I found that was the best way for me to go about my fasting, getting that 16 and 8. And fasting allows you to clear the senescent cells. It upregulates the sirtuins. It upregulates the AMPK genes. It does so many crazy awesome things for your longevity genes. So fasting, eat less food, be hungry. That allows your brain, the hunger part allows your brain to do its thing, to really kickstart all those genes. I will get there eventually. I struggle on the day, but they'll kickstart all those genes. And when you do that, it allows you to really, 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 really lengthen your life and give you a better health span. And I know it's been coined, that term, by a lot of scientists now. It's a health span rather than lifespan, because you can live a certain time for a long time, or a certain time for 100 years or so, but your health span goes to about 60, and then it starts to decrease where you get diseases. You start to not live. You're not living like you were when you're 30, 40, whatever the case may be, whenever you felt your best. So these things are going to let you do that. So fasting, be cold. And if you're in a cold climate, excellent. Feel cold, get goosebumps, get the cold feeling. That also stimulates all those things. The brain goes, I'm in a harsh environment. I need to live longer. I'm going to bunker down. I'm going to really defensive in my body. It's going to create more structure in the cells. It's going to do a whole host of crazy things, amazing things. So get cold, get hot heat, be in the sauna, do all those things. As long as these things don't actually damage your body, which they don't, so don't go in there and go hurting yourself when it's cold, like getting frostbite and things like that. Don't damage your body in that regard. Be cold, be uncomfortable. Don't go to pain, don't go to anything like that. Be uncomfortable. The next thing you can do is to cut down on your meat consumption. It turns out the amount of amino acids we get is obviously turns those, upregulates the, I've had a complete blank, but one of the gene buckets, I've totally lost what it was called, the mTOR. We want to have less of that. The less of that, the better our body is at longevity, the better at it is that it creates and repairs the cells. So less amino acids from your meats and things like that. We can get all our essential amino acids from other places as well. So eat less, hot and cold, eat less meat as well, and exercise. Exercise is the last one, and it's been known for ages, hasn't it? So that exercise is good for your health. But it turns out that it's good for your health because it activates these longevity genes because you're uncomfortable. Uncomfort is where you want to be. And the more uncomfortable you can be, the better off you'll live longer. So get in your head and start to change the way you think about uncomfort and being uncomfortable. And the more you feel uncomfortable, they'll know that the longer you're going to live, the better you're going to live, the healthier you're going to live. Now, that's it from me. I hope you really enjoyed this episode, and hi to everyone on the YouTube, and I hope you all enjoyed the YouTube video that is uploaded around Thursday, I believe, in Australia. So in Thursday about 10 o'clock in the morning. Until next time, stay limitless.